In this lesson, we're going to be covering ions and what they are, naming ions, and how to draw Bohr energy level diagrams for ions. So, monoatomic ions are single atoms that either have more or less electrons compared to their atom counterparts, and they're gaining or losing electrons in order to become more stable. So atoms of representative elements, so group 1, 2, 13 through 18, form the same stable electron structures as atoms of the nearest noble gas by losing or gaining electrons. You can't predict the charges for transition metals, so that's group 3 to 12. So if we look at our periodic table here, if I get rid of all this stuff, okay, they're saying that you can't predict what your charges are going to be if you're talking about transition metals, which are right here, so from group 3 to group 12. Okay, but the earlier point is group 1, 2, and then 13 through 18. All of these elements, if you have an atom of an element from one of these groups, okay, and if that atom becomes an ion through either gaining or losing electrons, they're going to have the same stable electron configuration as an element in group 18. So basically what that means is they're going to have a full outer shell or a full valence shell. Okay. For boron, carbon, and silicon in group 18, they do not form ions. And hydrogen atoms, they can either form a cation, so a cation is a positive ion, so that is a term that you need to know what that is. So when a hydrogen atom forms a cation, we would call it a hydrogen ion, and then if it forms an anion, which is a negative ion, we would call it a hydride. So what this point is just saying is that hydrogen atoms, they can either form positive ions or negative ions. Okay, so why do ions form? Atoms form ions so that they can have the same number of electrons as the nearest noble gases, or have a full outer energy level. Okay, and the reason why they want this is so that they can become stable, because if an ion has a full outer energy level, it is more stable than if it doesn't. And everything in chemistry wants to move towards more stability. So how are ions formed? So let's first talk about anions. So those are your negative ions. Again, you need to know this terminology. So anions, they are going to form by gaining electrons. Remember that electrons have a negative charge, so if you gain electrons, you are going to become negative. So the type of elements that form anions are going to be nonmetals. Okay, the exception being hydrogen, because hydrogen can either form a cation or an anion. So if I go back to my periodic table, Okay, if you're trying to find your nonmetals, you're going to look for the staircase line that was pointed out in an earlier lesson, and anything to the right of the staircase, that is a nonmetal. So here in this diagram below, we have an atom of oxygen. Okay, and this atom of oxygen has 6 valence electrons. So if I count 1, 2, 3, 4, 5, 6. So in order to become a full outer shell, or a full outer orbit, the oxygen atom needs to gain 2 electrons to have a full outer shell. So where are we getting this, this value of 8, meaning that it has a full outer shell? Well, if you look back in your notes, okay, oxygen is in the second period, so it has 2 energy levels, and we've said previously that the second energy level can hold a maximum of 8 electrons. So that's why oxygen gains 2 electrons. Now, when we're representing an ion, you're going to want to have these square brackets around your diagram of the ion, and then write the charge in the top right hand side of your diagram there. Okay. The other type of ion that can form are positive ions, or also known as cations. These are formed by atoms losing electrons. So again, remember, electrons have a negative charge. So if you lose a negative charge, you become more positive. So the types of elements that are going to form cations are metals. Again, the exception is going to be hydrogen, because it can form a cation or an anion, but hydrogen isn't a metal. It's a nonmetal. Okay. So, for example, here we have sodium that has 1 valence electron. So in order to become stable, it's going to lose that 1 valence electron so that it has a full outer shell. Okay, and that full outer shell has 8 electrons. And again, what we're going to do is we're going to have these square brackets around the diagram, and then since it only lost 1 electron, it has a positive 1 charge. Okay, going back to that oxide ion, okay, it gained 2 electrons, so that's why it has a 2- charge. Okay, so let's draw some examples for ourselves here. Okay, so draw a Bohr diagram for the atom and the ion of the following. What is the name of each ion? All right, so starting with lithium, we're going to start out with the atom, and I'm going to draw it over here. Okay, so I'm going to draw the nucleus, and then let's look at where lithium is. So lithium is right here. It's in group 1, period 2. So I would expect that it has 1 valence electron, and it has 2 energy shells, or orbits. Okay, so 1, 2. If I look here, I notice that lithium has 3 protons according to the atomic number, and to figure out the amount of neutrons, I'm going to take the atomic mass, round it to the nearest whole number, so 7 minus the atomic number, 3, that's going to give us 4 neutrons. Okay, so 3 protons, 4 neutrons. Now, the lithium atom, so that's where our protons, or our amount of protons, is equal to the amount of electrons. Okay, so I'm going to start off with 3 electrons. The first orbit can hold 2 electrons, a maximum of 2 electrons, remember. So I used up 2 electrons, I have 1 left, and that's going to be our valence electron. Now, with our lithium ion, So the protons and the neutrons, those are going to stay the same. It's only the number of electrons that are going to change for an ion, and also for ions, the amount of protons is not equal to the amount of electrons. So we still have 3 protons, we still have 4 neutrons, but what's going to happen as we go from a lithium atom to a lithium ion is we're going to lose that outer electron, so that valence electron. How do we know this? It's because lithium is a metal, so it's to the left of the staircase. That's how you know it's a metal. And so what happens is we have our 2 electrons, and since it lost that 1 electron, I'm going to surround this with square brackets and have it as a 1 plus charge because it lost 1 electron. Okay, so looking at this, I just want to make sure, okay, what is the name of each ion? So let's just replace this. Okay, this is just called a lithium ion. So with metals, how you name the ions is you take the element name and then you just put on ion. And even though it wasn't very clear, those are 2 separate words. So lithium ion. This right here is just a lithium atom. Alright, let's do the same thing for sulfur. And I'm going to put a line right here just so it separates the 2 examples. Okay, so sulfur, I'm going to start off with my nucleus, draw that a little bit bigger. So let's find sulfur. So sulfur is over here, so it's to the right of the staircase. So that means it's going to be a non-metal. So we're going to expect this to be gaining electrons because it's a nonmetal. So for our atom, it's in group 16, so I'd expect that there's 6 valence electrons, and it's in period 3, so I'd expect that there are 3 energy levels to it, okay, or 3 orbits. There's 16 protons for sulfur, and if we're figuring out the neutrons, what I can do is I can round the atomic mass to the nearest whole number, subtract the amount of protons, and that'll give us 16 neutrons. So just FYI, the number of neutrons is not always equal to the number of protons. It just so happened in this case that was the situation. But please note, for all elements, the protons are not necessarily equal to the amount of neutrons, although sometimes that does happen. So 16 protons, because the atomic number was 16, 16 neutrons. It's in period 3, so I expect 3 energy levels. This is for a sulfur atom. Okay, so the max amount of electrons for the first shell, so the maximum amount of electrons for the first shell, that's going to be 2. Okay, so I'm going to start off with how many electrons I have, and remember, for atoms, the amount of protons is equal to the amount of electrons, specifically for atoms, not for ions. So 2 in the first shell. So I'm going to take away 2 from my running tally here. And then the next shell can hold a maximum of 8. So I'm going to take away 8 electrons. So that's going to leave me with 6 electrons, which are our valence electrons. Okay, which matches up with the group number of 16, the last digit tells us that, yep, there's 6 valence electrons there, so that checks out. Okay. Now, to name a nonmetal ion, what you're going to do is you're going to look at the element name, and you're going to change the ending of the element name to IDE and then add ion. So in this case, it's going to be sulfide ion. So because we're talking about an ion, the amount of protons does not equal to the amount of electrons. So let's start off with our diagram here. Okay, so because it's a nonmetal, we expect this to gain electrons, and we're going to gain enough electrons to fill this outer shell. So I'm looking here, and I know that the third shell or energy level, whatever you want to call it, it can hold a maximum of 8 electrons. So how I'm going to write this is going to be 2 electrons in the first shell or energy level, 8 electrons in the next energy level, and then 8 electrons in the outermost shell. And let's fill in the nucleus here. Again, for ions, the amount of protons and neutrons will not change. It's just the amount of electrons. Now, since this sulfide ion formed by gaining 2 electrons, I'm going to put square brackets around this and write 2 minus, because we gained 2 subatomic particles that have a negative charge each. So that's where that 2 minus comes from. Okay. Now, one last thing to cap off these examples, and we're kind of going above and beyond the question here, how you would represent the symbols of each of these is a lithium atom would just be Li. A lithium ion symbol would be Li1+. For a sulfur atom, that would be just a S. So I'm getting these symbols from the periodic table. So sulfur is S, and then lithium is Li. And then for the sulfide ion, I'd go S2 minus to represent the charge. Now, if you're thinking to yourself, how am I going to remember this for every single element? Well, the main goal is to have a full outer shell, and you can either accomplish that through losing electrons or gaining electrons. Metals are always going to lose electrons, and nonmetals are always going to gain electrons. Another thing that you can find in your periodic table that's quite helpful, okay, is it'll tell you what charge the element typically likes to have. So lithium, there's that 1+. Okay, with hydrogen, it shows you that, well, hydrogen can either form a 1+ ion or a 1- ion. Okay, so either a cation or an anion. Okay, beryllium likes to form an ion with a charge of 2+. Okay, if we go over to the nonmetals, if we look at sulfur, it says right here, sulfur likes to form an ion with a 2- charge. Phosphorus likes to form an ion with a 3- charge, so on and so forth. So for this next section, it's just going over what I've said, but this time we're writing out what I'm saying. So with naming ions, for cations particularly, they are positively charged, and how you name them is you use their full atom name with ion at the end. So because most cations are metal, with the exception being hydrogen, which is a nonmetal, okay, that's why when I was naming it, I said lithium ion. So you take the element name and then you just put ion at the end. And a reminder that you do need to know that cations are positively charged and anions are negatively charged. Okay, so for anions, how you name them is you change the ending or the suffix of the element name to IDE and then add ion. So sulfur changed to sulfide and then you added on ion. For some more examples here, for phosphorus, we would change this ending to IDE, so that would change if we were trying to represent or name ion of phosphorus, we would call it a phosphide ion. Okay, with chlorine, change this ending here to ide, so chloride ion. Okay, for oxygen, it would be oxide ion. Nitrogen would be nitride ion. So on and so forth there. Okay, my rule of thumb is, like, for figuring out where to change the ending to IDE, if you sound it out and if it rolls off the tongue, it's gonna be likely what the ion name is. Okay, so for example, bromine, the easiest way to have that roll off the tongue is if I change the ending INE to IDE and just say bromide ion. Okay. So these 2 points are important. You do need to know that cations are positively charged and how to name cations. You also need to know anions are negatively charged and how to name anions. For the practice questions, please refer to the lesson guide to see which questions are assigned. Moving on to multivalent ions, those are metals, well, transition metals, that have more than one possible charge. And because they have more than one possible charge, when naming the ion, you need to specify which charge you're talking about. Okay, so if we look at our periodic table, so again, our transition elements are from group 3 to group 12, notice that some of them have more than one charge listed. These are your multivalent metals. Okay, so because there's more than one option, that's why you have to specify what the charge is. And in doing so, you're going to represent the charge using Roman numerals. So let's say I was trying to represent a chromium ion with a charge of +3. So how I would name that ion would be a chromium 3 ion, and I'm going to use Roman numerals to represent the charge. So chromium 3 ion, the symbol for it would be chromium 3+. Okay. As a quick refresher of Roman numerals, 1 is going to be just that. Okay, let's create a little table. The Roman numeral for 2 is that. Roman numeral for 3 is that. Roman numeral for 4 is this. Roman numeral for 5 is this. This is going to cover you for the vast majority of cases here. If there happens to be an ion with a charge of 6, it would be represented by this with Roman numerals. Okay, but that should have you covered for all the different charges for the multivalent metals. Okay, for polyatomic ions, what they are 2 or more atoms so closely bound that they're going to act like one unit. So when you're naming them, you should keep the name exactly as it appears on the table of polyatomic ions. So what they're talking about, if we look at our periodic table, okay, we have the table of common polyatomic, should be ions, not icons. Okay, so they're saying here that the names you see for these polyatomic ions, do not change them when you're trying to name a compound. So, for example, OH1-. If we look on our periodic table, let's see, these are organized from top to bottom alphabetically. So, if I see OH1-, that's a hydroxide ion. SO4 2-. So what that means is the 1 sulfur and 4 oxygens, like they are bound so closely, they act as one unit. All of this has a charge of 2-. If I look at my periodic table, okay, that's going to be right here. So that is a sulfate ion. Okay, now just FYI, there's 2 different ways to spell sulfate, either with an F or a PH, both are acceptable. So you could call it sulfate ion like that, or sulfate ion like this. Okay, but just watch out, because, okay, sulfate ion is SO4 2-, but remember, this sounds very similar. Sulfide ion is S2-. So just watch out for that. Typically, your polyatomic ions, most of them end with ATE or ITE. So if we look here, let's get rid of that. Oop. There are exceptions, but most of them end with ATE or ITE. Okay, 8, 8, so on and so forth. Let's find some ite examples. So hypochlorite, nitrite, sulfite. So the endings are very important. Typically, if it ends, if the ion, the beginning of the ion name ends in IDE, you're typically just talking about one element. Whereas if it ends in ATE, 8, or ITE, ite, that's going to be, you're going to have more than one element, and it's going to be a polyatomic ion. Okay. So for sketching Bohr ion diagrams, remember that when atoms lose or gain electrons, they turn into ions. So a cation example, magnesium atom becomes magnesium 2+ ion by losing 2 electrons. Any atom that loses electrons becomes positively charged and is called a cation. Okay, so these Bohr diagrams aren't accurate because you should be showing each energy level, but the whole point of these diagrams is to illustrate that the magnesium atom, as it becomes an ion, loses 2 electrons there. Now, how do you know that it loses 2 electrons? Well, you can look at the periodic table and see, oh, magnesium likes to have a charge of 2+. That's how you know it loses 2 electrons. Okay, for the anion example, the chlorine atom becomes a chloride ion by gaining 1 electron. Any atom that gains electrons become a negatively charged ion and is called that should be an ion. So again, with this diagram, it's not perfect. You should be showing each of the energy levels, but the whole point is to demonstrate that the chloride atom gains one electron to become a chloride ion. So let's write that in. Gains one electron. And let's also write that up here, but because this is a metal, it loses electrons, so loses 2 electrons. Here, just so that we're making those two diagrams a bit more clear. Okay, there are some practice problems. Please refer to the lesson guide to see what practice problems are going to be assigned.